In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thine intercession, was left unaided. Inspired by this confidence, I fly unto thee, O Virgin of Virgins, my Mother. To thee do I come, before thee I stand, sinful and sorrowful. O Mother of the Word incarnate, despise not my petitions, but in thy mercy hear and answer me. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Excuse me. Please take out your 6E-2 for surface area. And let's see what you get. This was entirely decimal.
That one was weird.
Sorry, Mr. Cook.
No problem. I'll be right back.
Hang on. I literally did.
All right. Thank you. Oh, this is the other.
Oh, I'm sorry.
6E-2.
Oh my gosh.
Yeah, no problem.
I literally did.
Okay.
That was actually mine.
Here we go. They were talking about rotating these things around the y-axis for all of them for 2 through 7. For number 1, that's the only one that was going around the x-axis. Number 1, the answer is 102.3778. 102.3778. Number 2, and these are all around the y-axis. Number 2 is 3061.9221. Any repeats of it? Okay, so for y-axis for all these, number 3, 26.6533. Number 4, 66.4382. 66.4382. Number 5, y-axis is 53.4013. Number 6, 37.7038. 37.7038. And number 7, 3.3849. 3.3849. Any repeats?
Can you repeat 3?
Number 3? Number 3, 26.6533.
Can you repeat number 1?
Yeah, number 1 was, that was around the x-axis, so that was 102.3778.
Yeah, that's true.
Any other repeats? Alrighty, questions? Any of those you want to see dissected? Ow, you got shocked. What?
Repeat number 7.
Yeah. 7, yeah, y equals tangent of x. Where x went from 0 to pi over 4. And it's about the y-axis. Now, it is a good idea to know how to graph this thing, but only for the purposes of knowing which way it's spinning and which way the radius is going. So if you remember way back when, tangent of x looks like this. It starts, we're counting by, normally we count by pi over 2s. But with tangent, the period is half as big. Normally, sine and cosine, the period is 2 pi. This period is 1 pi, because there are asymptotes blowing it up every single pi over 2, well, every single pi. So at pi over 2, it explodes. So this is pi over 4, this is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which is really 3 pi over 2, etc. So every 1 pi, the thing blows up. So you go negative pi over 2, 4, sorry. But if you remember this, a positive tangent has, let me move this thing. It should have, it doesn't have min and max because it goes forever, but it has a lower guide, baseline, upper guide, and it snakes up like this. And it goes toward the asymptote. The only piece they're worried about is this thing right here. Everything else you just sort of ignore, and they're spinning it around the y-axis. So we're going to have something that looks like this. A sort of little upside down beanie thing that's hollow. What I need to know is, first of all, what is the formula for surface area? Just in general. Let me tell you. Wait.
2 pi
Something before that. But yeah, I see you could do that.
r, right?
Before that. If you pull this out in front, there's something else.
The integral.
Integral, right. You can put the 2 pi inside or outside, doesn't matter. And then what?
R,
R.
radical 1 plus f prime of x
Uh-huh.
squared.
And then
dx.
dx, correct. Provided you have a function of x, which we do. So if the function has x as its inputs, you're good to go. Otherwise, you do f prime of y. Question. What's r? John, take over.
R would be X.
It would be x, correct. The radius of this thing is in the x direction. So you replace this with x. So what's f prime? The derivative of tangent.
Secant squared.
Secant squared. So y prime is secant squared of x. So what's y prime squared?
Secant squared. Squared.
Yeah, so secant to the
4.
4th power of x. Should we clear on that? On a calculator, you'd have to type it in like this. By the way, where's the secant key on the calculator?
It's just 1 over cosine.
Yeah, there isn't one. It's 1 over cosine. So you do 1 over cos parentheses x, close, close, to the power of 4. That's what you'll have to enter here. So if you have an old calculator, it'll look like this. It'll be FNINT and I'll keep the 2 pi inside because we're not going to get an exact answer anyway. 2 pi x radical, and it'll be 1 plus this mess. New parentheses, 1 divided by cosine of x. Close the cosine parentheses, close the fraction parentheses, raised to the 4th power, close the radical parentheses, does that make sense? Comma, x, comma, 0, comma, pi over 4. And that should do it.
Oh, Jack.
See what we get.
I just did multiply by pi.
Ah.
Oh.
So let me do math 9, 2 pi x radical. The most common cause of inaccurate answers here is just 1 misplaced parentheses. If you have 1 too many here or 1 too few over here, it'll either give you an error, that's if you're lucky. And if you're unlucky, it'll just say, oh, you mean something completely different. I'll give you a different answer. And nobody ever knows. So radical 1 plus parentheses 1 divided by cosine of x, close parentheses, to the power of 4, close parentheses, comma, x, comma, 0, comma, pi over 4. What mode should we be in?
Radian.
Radian mode. If you're in degree mode, you'll get a wrong answer. And I got 3.38489. 7659. And they wanted to round to 3.384. Does that make sense? Any other ones we're gonna see? Does that make sense? Think you could do these on the test? Again, it does have usefulness having a calculator do the heavy number crunching for you. This would be extremely difficult to do by hand. We don't even know what the antiderivative of 1 plus secant to the fourth of x is. But that's what a calculator's for. Any others?
Can you do, 5, please?
Number 5. Okay, y equals 1 over x minus 2. Let me try to read. Is everybody okay with this picture? Okay. This is another one where you might want to draw the sketch just so you know where the radius and things are. So y equals 1 over x minus 2. That's a diagonal hyperbola. Oh, basically, all you need, there's a vertical asymptote at x equals 2. And there's a horizontal asymptote at y equals 0. And the pattern is over 1, up 1, left 1, down 1, and it'll branch from there. And they wanted you to do it from 3 to 5. So this is 3, 4, 5. So just this little snippet here. And again, they wanted you to spin it around the y-axis. So you're going to get something that looks like this. This is sort of a phantom piece here. You're going to get this thing that kind of looks like a, I don't know, upside down plate or a hi-hat cymbal. And I want to find the surface area of this thing. Again, the only real reason we want to sketch this is to find out which way is the radius. So let's do it. Surface area equals the integral of 2 pi r radical 1 plus f prime of x quantity squared dx. As long as we have a function of x, which we do. We do have to find y prime. Let me do that for me. How? Go.
Well, I put the bottom part in parentheses.
Okay.
Into the first, and then moved it up, made it negative first.
Good. You can write it as x minus 2 parentheses negative 1. Now take the derivative. How do you do that? I take the derivative of something that looks like this. Yeah.
Chain rule.
Chain rule. It's going to be blah to the negative 1 power. So negative 1 times blah to the negative 2 power. Technically, the chain rule says what pops up at the end. It's boring, but what's the derivative of x minus 2? Anyway, 1. Right. That is the chain rule, so it's not going to do much, but oh well. So the y prime is equal to negative 1 over parentheses x minus 2 squared. Now you have to square it. So y prime squared is positive 1 over x minus 2 to the 4th. Think you follow that? So you square the top, square the bottom. Now let's set this thing up. It's equal to the integral of 2 pi, you tell me, what's the radius? X, y, dx, or dy? Polly. It's x, right, because it's in the x direction. So 2 pi x, radical 1 plus parentheses 1 over new parentheses x minus 2 to the 4th, close parentheses, dx. That makes sense? That's in calculator notation. So let's do it. And from what to what, Pete?
It is going,
Like from what to what?
it's going
From
from 3 to 5.
3 to 5, right. Let's try it. So we've got math 9, 2 pi x radical 1 plus new parentheses 1 divided by new parentheses, bless you, x minus 2, close parentheses to the power of 4, close another parentheses, then close the radical parentheses, comma x, comma 3, comma 5. See what you get. Okay, this is number 3, right? Oops, scroll off screen. Darn it. Over ambitious. Oh, wait a minute. Oh, this is number 5, sorry. You're asking, right? Wait, did you ask for number 3? No, 5, okay. Wait, did I just type in the wrong problem? It should be, I got this, approximately 53.40126,395. And that would round to approximately 53.401. Any other questions? Feeling a little better on these?
Well, Mr. Buckland,
Mhm.
would you accept the decimal we get? Say we took the pi out and just put a decimal without pi. Would you want us to multiply pi?
Oh, the question is, if you have a weird decimal and then you just put a pi afterward?
Yeah.
Wow. I've run into that before.
Probably should be better to multiply.
Technically, yes, I would accept that.
Okay.
I'd have to do an extra 3 minutes of work and I'm kidding. But, do you have to? No. It is technically a little more accurate when you do that, because pi isn't being rounded, so a rounded number times a rounded number is an even worse rounded number. But, I'll leave it either way.
It's probably easier for me just to multiply that pi. And then,
Doesn't make any difference to me, it actually only takes me like 10 seconds.
I don't know, that's 10 seconds.
It's basically, well,
That can make
it's
us all
10
minutes.
seconds out of my life.
Yeah.
I could have spent eating a potato chip or something. But no, we're good. Everybody good to go? Going once, twice, thrice? All right, welcome to the last section of the chapter.
No.
The test is coming.
It is. We had tossed this around at the beginning of the chapter.
2 days.
So hopefully at least a little part of your brain would at least say, this sounds vaguely familiar. Here's the worksheet. This is 6F-1. Yeah, you're welcome. This is not rotational solids. This is, what if there's a blob sitting on the ground, but if you slice it, each slice is a shape you recognize. Take a look, if you will. Number 1. I'm just going to start this notes by doing number 1 together. The base of a solid is the region enclosed by blah and blah. Now, in other words, there's this sort of three-dimensional thingy made of, Play-Doh or Jell-O or cheese or something, and it's just plopped onto the table. And the bottom shape, like the bottom is like you wham it down on the table, and then you look at the bottom and say, oh, it's flat. And then the flat bottom is shaped like those two graphs. It look like this. So number 1 looks like this. Y equals, they wrote negative x squared over 9. I'm going to write negative 1/9x squared. That's closer to standard form. And y equals 0. Can somebody tell me what shape this is? It's a parabola. Tell me about it, please. Anything interesting about the parabola?
It's got a negative
Mhm.
height multiplier, so does that mean it's upside down?
Correct, it's upside down. Is it going up, down, left, or right? Down. How do you know it's not going left? Yeah, question.
Sorry, it just has a +4 then, just so you know.
Oh, does it?
Yeah.
Oh, yikes, thank you. Yeah, why not left?
Because it's dealing with the y, not.
Yes. The y equals, you follow the leader. Whatever the parabola is, the leader variable you follow it. So, set up a mess here. What else? How do you graph something like this? Where's the vertex, Jack?
The vertex,
Of this thing?
it is,
Let me get rid of the and. Negative 1/9 x squared plus 4. Where is a vertex if nobody moved it anywhere?
0, 0,
0, 0. Did they move anything?
plus 4,
Plus 4. Which direction did they move it?
be up,
Up 4. So where's the vertex?
so 0, 4.
Correct. The vertex is at 0, 4. They did not move it left or right, otherwise we would have seen parentheses, x minus something or x plus something. And can somebody tell me the pattern I would use for this thing? What's the normal pattern of a parabola, Polly?
Up one, over one, up.
Other way around. Over 1,
Over one, sorry, over one, up
1.
and then over two, up 4.
Good. And over 3, up 9. What's this gonna do? Over 1? Normally, only it's
Oh, down.
down. Correct. This one, over, up. You might want to write this chart down. And you know, normally I only do a few of these. Over 1, up 1, over 2, up 4, over 3, up 9, and I usually stop after that. I'm not going to stop yet. I'm going to go out to 6. I'm curious if anybody knows why. First of all, let's do these height multipliers. So what did you say this first one was?
1/9.
Yeah, and first of all, it's going to be down, and 1/9. I'm sorry?
Yeah, never mind.
Yeah, or you just do up minus 1/9, I suppose. Is that what you asked her?
Yeah, it's
Okay.
saying it's negatives.
Yeah, exactly. What about this one? Jill?
4/9.
4/9, exactly. Take another one.
Over one.
Yeah, 9/9,
Down one.
which is 1. Try the 4th. No, take over. What are the normal ones?
16,
16,
25,
25,
36.
yeah. Keep going.
So 16 ninths,
16 ninths,
which would,
which is,
just 16 ninths.
yeah, just 16 ninths. Next
And
one.
then 25 ninths,
25 ninths, which you're still stuck,
36 ninths,
which is
4.
4. Why did I go that far down? Normally I never go out 6 spaces. It's like the graph goes way too big.
It's a whole number.
Yeah, it's a whole number. Look over here. Could you graph over 1 down 1/9? Yeah, you could. You have to label it. So if you do that, which means that there's absolutely nothing, illegal about it, but you would have to mark this somehow as being, this is 4, this would be like 3 and 8/9. You'd have to tell me somehow that that first jump was at 3 and 8/9, which is a bit of a pain. You can do it. But I'm particularly interested in this one. Over 3, down 1. You may notice how enormously short this thing looks. That's probably the wrong way to put it. How ridiculously short this thing looks. Normally it torpedoes down like this. And the next nice one is over 6, down 4. This is an extremely slow descending parabola. Make sense? So that's a review of how to graph that. They also wanted to graph y equals 0, which is a horizontal line on the x-axis. The whole reason we did that is to get the shape of the bottom. This is like a lump of silly putty or whatever, and I go ka-thump up against the whiteboard, and that's what the bottom looks like. That's the shape. It's like a half moon. Not quite. Make sense? That's a third of our battle. It says cross sections perpendicular to the x-axis are semicircles. Now you have to use your 3D imagination here. Let me take just a cross, what does it mean cross section? So there's this lump sticking out at us from the board. So it's going, and then if you took a knife and sliced, what would the slice look like? What shape? What does it say? So it's a semicircle. So if I sliced it right here, again, it's hard to picture, but you would have a semicircle slice. Make sense? You'd have a whole bunch of semicircle slices, one after the other. Can somebody give me the volume of one slice? What shape is that? Pete?
Some weird half circle.
Yes, true. By the way, what's the fancy word for half circle? Semicircle. What if they gave it some thickness? It's not half a circle anymore, but close. Half of a what? We've been playing with these for weeks. Anybody know?
Half of a cylinder.
Half of a cylinder. If you have a cylinder, like a really, really thin cylinder, let's do like that, and you cut it in half, like half of a pill, it's half of a cylinder. So give me the volume. John, take over.
So, one.
It's half of a what?
Cylinder.
Cylinder, go for it. One half of,
2 pi r, or sorry, pi r squared h.
exactly, not two. Yeah, 2 pi r ht is for shells. Pi r squared h is for that. So take half of a cylinder. Good. Can somebody tell me what that is? Slice is going to be 1/2 pi something squared times something. We do it the same technique we've been using for the rotational solids. It's just, this is going to be a teeny bit tricky, but try it. People who remember your geometry, what do you call this distance? Paul. If this is a circle, if you go all the way across it, what's it called?
Diameter.
Diameter. What do you call this?
Radius.
Yeah, radius. Look over here. This is the center of your circle. What do you say this was again?
Diameter.
Is that x, y, dx, or dy? Everybody pay attention on this. You could get lost really fast. Is this x, y, dx, or dy? What do you think? It's y. So y is equal to the diameter. I don't want the diameter. I want the radius. What?
1/2 y.
1/2 y. Very good. Make sense? What's the height? Now, you have to kind of imagine, in real life, it looks like this, sticking out at us, like that. So it's a very small, very, very razor thin slice. Is it dx or dy? No. It's dx, because the thickness is still extending in the dx direction. If it were dy, if the thing were lying like that and poking out at us, it would be dy. This is dx. So we're looking at the volume of a slice is equal to, could somebody actually expand this for me? Yeah, go.
So you could,
There's 1/2 pi and then what?
so you could divide, oh, sorry, never mind.
What the half y when you square it?
1/4 y squared.
Yeah, 1/4 y squared, dx. Now that's one slice. How do you get the total volume? Pete?
You take the integral,
Integral. From what to what, do you think?
the integral,
Well, actually, go ahead. Are you going to be using x's or y's, do you think? Something in here will tell you.
probably x's.
X's, why do you say that?
Because.
Because there is a y here, but I agree, it's x's. Why?
Well, there's a dx.
How come?
There's a dx.
Right. The dx is going to command you on where you need to go. The dx says basically use x's. Now, we do have a problem. Jack, what's the problem with this thing?
There's still a Y,
There's a y in there. Fix it.
so you have 1/4. So you can.
Okay, and by the way, I would just pull the 1/4 out in front. What's a half times a fourth?
1/8.
1/8, and pull the pi out. So what do we have so far?
1/8 pi.
Yep. Times the integral.
The integral of, negative 1/9 x squared plus 4 squared.
X squared plus 4 parentheses squared, and then what?
Oh, sorry, dx.
dx, good. From what to what? Now that we know I'm doing x's, look at the picture, original picture. That's another reason we needed to graph it, because, go. No.
Negative 6 to 6.
From negative 6 to 6. There were two options. You could either go from negative 6 to 6 or from 0 to 4. It depends on which variable you're using. In this case, they wanted x's, so we're going from negative 6 to 6. Now, this is kind of up to you. Can you expand this out? Yeah, it's not too hard. Square the first, double the product, square the last. Do you have to? No. Partially because we're not going to get exact answers anyway. If I thought there was a prayer of getting an exact answer here, well, maybe. Oh, that's tempting. But tell you what, leave the pi off and do this integral. Try it as a bit. And you'll have to multiply by 1/8. So 1/8 times math 9. And I do extra parentheses, negative 1 over 9. Fluffer numbers. Negative 1 over 9. X squared plus 4, close the first parentheses, squared, comma, x, comma, negative 6, comma, 6, close parentheses. Now this is without the pi. I got a very nice answer. What do you get? Relatively speaking. Have got it? What's it?
12.8.
12.8 is exactly right. Now, what you got is 1/8 of it, whoops, it's pi times 12.8. Can somebody give me a fraction reduced exact answer? What's 12.8 as a fraction? Anyone know?
64 over 5.
Give me your final answer.
64 pi over 5.
Congratulations, you just got your shape volume. Does that make sense? So the trick is, what shape is the slice? And then you notice we couldn't use all of y, because all of y wouldn't have been the radius we wanted. That would be the diameter. So this thing, we had to use 1/2 y. Does that make sense? That was the tricky part of this. Are semicircles the only shapes they'll ever use? Nope.
The next one is squares.
The x-axis are squares. Now in that sense, it's almost easier. That means whatever this is, like if I did squares, let's just say this is y, and it extends out like this. Let me see if I can do it. How would I do a three-dimensional thing? Like that, kind of, sort of. That's a square. It's going to be y times dx. Make sense? For the volume of that box. And then just add those up. And then fix the variables. So we've got semicircles, we've got squares, equilateral triangles, and semicircles. So number 5 is a duplicate of number 1 with different numbers. Equilateral triangles. About a month ago, I gave you the area formula for an equilateral triangle. Anybody have it in notes? It was about March 26th, thereabouts. March 20-something, I think. What's the area of an equilateral triangle if S is the side? I'll give it to you if you can't find it. If S is the side, I usually don't like using S because it looks like a 5, but oh well. The books use it. Okay, go ahead and write this down. S squared radical 3 over 4. Or you could write it as radical 3 over 4 S squared. That's the equilateral triangle area. Why do I say that? Well, first of all, it's true. Second of all, if you have an equilateral triangle, let me draw something that looks equilateral. So all these are the same. And if you make it thick, this would be, to get the volume of anything, you take the base area times height. That's how you get a cylinder, that's how you get a prism, that's how you get, and this is a prism, by the way, it's a triangular prism. Base area times height. So if you can find the base area, multiply it by a teeny weeny little height, which is probably gonna be dx, or dy, depending on which direction it goes. I think it's gonna be dx. Does that make sense? Like here, if you could get the area of a half circle, actually take a look over here. That's actually true. Look at this 1/2 pi r squared times h. 1/2 pi r squared is half of a circle times height. So if you can get the area of the slice, just make it thick by multiplying it by a thickness, and that'll give you the volume. Make sense? For a square, you just take the area of a square, which is base times base, and then multiply it by thickness. Does it kind of make sense? Okay, 2. Rest of the hour is yours. Go ahead, we start pounding. Wow, I cannot talk today. Start pounding away at this. This is, again, 6F-1. I would like you to have this done tomorrow. And we'll see what happens.
Bye, Michael and Julia.
Thank you very much.